Do you need to test a Python project across multiple Python versions, maybe with and without optional dependencies, or maybe with different versions of dependencies? You need to learn about Tox and Nox. Or do you just wonder why so many open source projects have a tox.ini or noxfile.py in their repo? Then you too have to learn about Tox and Nox. Hello Internet, I'm Henrik, a software engineer with more than a decade of experience in writing Python in general and maintaining high-profile Python projects with strict backwards compatibility requirements in particular. So let me use this video to break down the differences between Tox and Nox, show you how I use both as a software engineer at a hosting company with high quality standards and as a maintainer of way too many open source projects with many millions of monthly downloads and very different needs. And at the end, let me demonstrate how I decide, depending on many factors, which one to use. Because one thing is clear, they're both great. They're both used by high-profile projects. They're just different. And not just by the way that Nox is capitalized and Tox is not. Deciding between them is not choosing between good or bad, or even good and better, but between how they work and what fits your project better. But let's not get ahead of ourselves and start with what they do and why you should bother learning them at all. Because I've met many smart and senior people who have a vague understanding of them, but aren't quite convinced it's worth their time. Because if you want to run tests in Python, you can just run PyTest, right? Now you may want to somehow encode how to run your test runner to make sure that it's run always the same way. For example, locally while developing and in CI to prove that you actually run it locally. And you want to encode it programmatically instead of putting that information into a README that is out of date before you've committed it into source control or taking it to a wiki upstate. And both Tox and Nox can help you with that because they do allow you to run arbitrary commands. But it would be very interesting because we've been using Python tools like Fabric and Invoke since 2008, Makefiles since 1976, and shell scripts since 1973. And they're all perfectly adequate to standardize programmatically how commands are repeatably ran in projects. So what Tox and Nox sets apart is that they allow you to run that PyTest command line in different kinds of Python environments. For example, different Python versions with and without optional dependencies and with various versions of dependencies, optional or not. In other words, they are an abstraction over virtual environment management and over Python packaging, which generally speaking is a good thing to have an abstraction over. They make it very easy to create virtual environments that fit certain constraints and to install Python tools and packages into those environments. And they do it all in a cross-platform way. So now that you have the means to create virtual environments that satisfy certain constraints, it is a very short leap to allow the user to define several of them and create a kind of multi-dimensional matrix of combinations of constraints that you all want your command to execute in. For example, if you want to run your tests on various Python versions, each with the oldest and newest supported versions of your dependencies, that's 2 dimensions right there. And if you've been using CI systems like GitHub Actions, you have probably encountered the strategy matrix. So in this case, it consists of 2 dimensions, the operating system and the Python version. And the jobs steps are run a total of 15 times, 5 Python versions times 3 operating systems. And Tox and Nox offer you something similar, but focused on Python packaging related features. So they have nicer features around package management, but they can't change the operating system like a CI can. Unless you use them to run Docker, which is completely nuts, defeats the complete purpose, but who's gonna stop you? Not me. Go wild and be free, my wayward viewer. Now, due to Python packaging's nature, people have used both Tox and Nox for a long time to not just run their tests, but to run Python tools in general, like linters, type checkers, or other helper scripts. But of course, they don't just run Python applications. They can run any command you want. But that's not where they shine. For example, as someone who isn't only developing in Python, I use Justfiles with the Just tool to run Tox and Nox, so I have a stable project interface across platforms and languages, and I don't have to remember what tool I'm using where. It's always just test, or just check all, or just deploy. And I would love to tell you more about how I use this wonderful tool, but nobody wants this video to be 3 hours, 33 minutes and 33 seconds long, right? So I had to unceremoniously cut this tangent short and get back to Tox and Nox. which you also may not need if you just want to run Python scripts in virtual environments. Because modern workflow tools like PDM, Hedge, Rai, or Poetry do all have the concept of running commands in virtual envs with varying degrees of power and comfort. And for completeness, I should also mention that Hedge has matrix functionality, but it's lacking certain features to make them useful for me, so I won't be talking about them in this video, but it might become more relevant in the future. So now you know what talks and nogs are good for. This could, and I guess should, be a video by itself, but I'm only getting started, so still interested? Cool, thanks for not closing the tab. And let's look at how they differ by contrasting how they work and solve certain problems. But let's start with our superheroes' origin stories. And Talks is really old. Its first public release hit PyPI in 2010. That's back when Twitter was still fun. This is also the reason why Talks is used by many more projects and has a more mindshare. It's been around forever, which makes it the obvious default choice. Currently it has a whopping 14 million monthly downloads, while Nox has still very respectable 2 million. Its original author is no one less than Holger Krekel, who also started the PyTest project. Yes, that PyTest. And a huge rewrite happens in 2021, led by Bernard Gabor, who currently maintains the virtual env package. Yes, that virtual env. The virtual env that both Talks and Nogs are using by default to create virtual environments, because the built-in venv module in the Python standard library is glacial. However, both also nowadays allow you to use the brand new UV that my last video was about, and that's even faster. While not a spring chicken itself either, Nogs is a lot younger than Talks. Its first version landed on PyPI in 2018, so Talks was at that point already in primary school. And it was started by Thea Flowers for the simple reason that she needed something more flexible than Talks, which brings us directly to the biggest and most profound difference between Talks and Nogs, and that's the file format. Talks uses an INI-based declarative domain-specific language, or DSL, which is the simplest possible configuration format. It's essentially just sections in square brackets and key-value pairs separated by equal signs. And on the other hand, Nogs uses Python. And we will see the difference is not just about syntax. It percolates through all the difference between those two. And personal preferences aside, none of them is better or worse. Declarative formats are often idealized, but declaring something doesn't make it automatically great. And while in packaging we've been moving away from setup.py to static package metadata in a TOML file, I don't think that the reasons fully translate, because it's a different beast whether you're running arbitrary command on every package installation or whether you're preparing an environment in which you execute commands anyways. And B, there's good reasons why we still have projects that are rocking setup.py files, and why, contrary to common claims, setup.py was never deprecated, because it's actually quite hard to replace it in the generality that it offers. Now, both approaches have their upsides and downsides, which leads us to the circle of configuration life, where when you have a simple DSL, you yearn the power and tooling of a proper language. Every YAML programmer knows the struggle. And when you have a proper language, you're pining for the simplicity of a static declarative configuration. So let's try to approach both with an open mind and see what those differences mean actually in practice. And we'll do it by looking at simple examples of both. Let's say we want to install the current project into a test virtual env together with an optional requirement group called tests that contains all dependencies required to run your tests, like PyTest. And we want to run PyTest on Python 3.8 to Python 3.12, which, as of recording this video, are the supported Python versions. Now in Talks, it would look like this. And as you can see, it's really nicely terse, which, spoiler alert, is Talks' biggest upside. The downside is that once it gets a bit more complicated, you need a deep conceptual understanding of how things work. But it's simple enough. We define a matrix of what Talks calls environments. In this case, the matrix is one-dimensional and therefore a list. It's only defined by the 5 Python versions specified in Talks' own version format, consisting of the word py, and the major and minor versions without any dots or any other separation. Talks calls this a factor. Next, we define the base environment that's always called test env, and that other environments will inherit from. This part will be important later. The extras field specifies the optional dependencies to use. Those are the ones that you would specify using square brackets when talking to pip on the command line. And the posargs thingy in the commands field is a nice way to allow passing arguments to PyTest while invoking talks. Simply add them behind a double dash. And this is all it takes. You save this file as talks.ini, run talks, and wait. Now let's make it a bit more interesting and add another factor. And let's say we still want to run tests on all those versions, but we also want to type check a file that demonstrates the usage of your API using MyPy. And a quick side note, do not try to type check your entire code base on all possible Python versions. It's not useful and often not even possible. But do make sure that you don't type check your API surface only against the latest version. Something will inevitably break, especially in the typing space in Python. For better and for worse, a lot of changes are coming in, things are improved and things break. Now, let's adjust the environment list and call our existing factor explicitly tests and introduce a new one called MyPy, because this allows us to add more type checkers later, like Microsoft's Pyrite, for example. Now, I don't know how to explain this kind of patterns to you, but I hope it's somewhat self-explanatory. This gives us 5 times 2 equals 10 environments, and we can list them using talks-l, which is kind of useful to check what's happening if you get entangled in all those patterns. And now you can run any of them by passing their full name to talks run-e. Or as of talks version 4, by specifying one of the factors with -f. So talks run-f tests will run tests on all Python versions, but no type checks. While talks run-f py3.12 will run all environments that use Python 3.12. And this is completely symmetrical in this context. The Python version has no special meaning. This is just matching of names. Of course, just adding a factor doesn't change anything. And if you don't adjust the test env2, your tests are just gonna run twice. So now let's make these factors meaningful, and we want to install different optional dependencies, and we want to run different commands for tests and for MyPy. So we use the factors to define both extras and commands, and this is how it looks like. You prepend the extras and commands with the name of the factor, followed by a colon, and that's it. It's still nice and terse, but you already have to understand how things work to fully grok it. And it has some weird special rules, like not being allowed to use backslashes to split up lines into more readable chunks. So now let's introduce one last concept. One thing I like to do with slower test suites is running only the oldest and the newest Python version under coverage. Because running under coverage is significantly slower than not, especially on PyPy, even with the new performance improvements in the latest coverage versions. Because coverage without measuring branch coverage is pointless. This is my hill. Here I will rest in peace. And to achieve that, I have to create a new test environment. You can see that I can use Tox's idiosyncratic pattern matching again to define it. This means that only the configuration of the two environments, py38 test and py312 test, is overwritten. And you may wonder, why don't I mention the extra call tests like before? Won't this environment miss PyTest? Turns out no. These two environments inherit everything from the base test environment, including extras. That's handy, but also implicit and profoundly confusing. Now, I've left out coverage combination and reporting, and Tox can do a lot more with factors and environments. But if I even tried to explain it all, we'd be here all day. But I hope I gave you a feeling on how it operates, declaratively with inheritance. But one thing is a bit deceptive here, and it's the commands option. It looks a bit like a shell script, doesn't it? You can even have multiple lines, hence the plural, commands. But there's no shell involved. Tox parses those commands and then runs them using Python's subprocess module. Otherwise, Tox wouldn't be cross-platform, and Tox works wonderfully on any Python-supported platform from Windows to FreeBSD. But it means that shell things like pipes and redirects of output in general, or even conditionals, don't work in Tox. And this leads people to occasionally run shell scripts from their Tox files, which kind of defeats the point and brings us directly to Nox, which was created to specifically fill this gap. So in Nox, the same example looks like this. And I'm gonna wager that if you know Python but never heard about Nox before, you're still gonna be able to take a very good guess at what it does. Try it. As you can see, what Talks calls environments, Nox calls sessions. You write functions and decorate them as sessions with parameters like what Python version you want to run it with. And the function is then run once for each Python version it's declared for. When invoked, it gets the session object passed as an argument that you can use to interact with the virtual environment that Nox has created for you, like installing dependencies or running commands. And you see there is no repetition. We just reuse a variable and use basic list slicing to achieve that the oldest supported and the newest supported Python versions run under coverage, and the rest does not. And if you're curious about any Nox API details, you just can press F12 or whatever your IDE's shortcut is for go-to symbol and read the implementation. And if you get confused about some behavior, just add a print statement or drop into PDB and look around in runtime. It's Python. When it comes to selecting sessions to run, Nox offers more and, in my opinion, also more idiomatic ways than Talks. For one, Python versions are a first-class concept in Nox. So when you run Nox --Python 3.12, it runs all sessions defined to run under 3.12. Unlike with Talks and its factors, the version does not have to be part of the name of the session. So configuring a session to use Python 3.12 is enough. Now, this can be useful in CI if you want to have one container per Python version. Secondly, choosing a session by its name without a Python version like tests no conf here will run it against all versions that the session is configured for. So the session name and its parameterization are two distinct concepts. And speaking of parameterization, Nox can also parameterize session like you might know from PyTest, which is really nice for optional dependencies. In this case, it installs the current package with its tests dependencies, and once with no additional dependencies, once with StructLog and Prometheus client, and once with Trio. But of course, it does so for every Python version. So this function is called 5 Python versions times 3 optional dependency lists equals 15 times in total. And finally, Nox has the concept of tags. Tags allow you to group sessions together, like in this example, to run both the sessions with and without coverage by passing Nox the argument --tags tests. I find these three concepts together give Nox a nice and intuitive way to choose the commands to run, while Toxes feel a little bit ad hoc and grown over the years, which is exactly what they are. Now, since Nox files are just Python, you can implement your own features, because turns out Python is Turing complete, so we can implement anything in a Nox file. For example, the only useful use for PyPI's trough classifiers I found so far is to explicitly enumerate the Python versions that your package supports knowingly. In modern Python packages, that information is usually in a pyproject.toml. So why not extract those supported versions programmatically? It takes 6 lines of idiomatic Python code. Now add my build and inspect Python package GitHub action that does exactly what the name says to drive your CI. Link to details in the description. Where are all those tangents coming from? I'm not getting ahead with my topic. And the package metadata becomes the only source of supported Python versions. This makes adding and removing them a lot less stressful because you literally cannot forget to add or remove it somewhere. But the power of the snake doesn't stop here. And it becomes even more obvious when you think about extending Talks and Nox. Because you've seen how to extend Nox, you've read some Python, and you can use any PyPI package in your Nox file to help you to do whatever you want to achieve. So you're mostly extending it from the outside, you're wrapping Nox itself. And therefore Nox does not offer an official plugin interface. And consequently, there isn't a lot of Nox specific helpers on PyPI, which could be more different for Talks, since a Talks ini is a domain-specific language based on the simplest possible file format, and every feature in Talks has to be implemented outside of your Talks ini and inside of Talks. Therefore, Talks has a very powerful plugin interface, and PyPI is full of plugins. And the same caveat applies to judging the project maintainer's activity. Talks is by most metrics the more active project, both by the number of PyPI releases and by Git commit activity. But it's also true that Talks needs more help to achieve things than Nox does. And once it was necessary to ship a Nox release to add support for UV, they did it within a month. So Talks' plugin was faster, but the few weeks difference don't really matter in hindsight. I mean, I would love if Nox grew support for parallel execution of sessions, like Tox has with run parallel or dash.p in the before times, but that's a feature request and parallelism is broken for me in Tox anyway, so it's kinda a draw. And as far as maintenance goes, Nox is just fine. It has multiple active maintainers. Thea just said that she loves releasing it, so all is fine. And I can work around most of its word anyway. So in other words, any comparisons of pseudo-objective raw numbers here must be taken with a huge grain of salt. Which leads us to the inevitable question, how to choose? How do I choose? And I've stressed it many times, both are great and both are worthy to be used by you in your project. But given my many years of experience with it, Tox is my default and it's my bias. It's TERS, which is great because I'm very lazy and I'm used to it. And I love Tox's built-in feature to share wheels between environments. With only like 2 lines of ini code, your Tox runs can get radically faster by building the package only once into a wheel and then reusing that wheel in all test environments instead of building a source distribution and installing it into each environment. One wheel is much faster than many SDists. So for projects with fast tests across many environments, the runtime difference can be dramatic. And in Nox, you can/must implement this yourself. It's no rocket science, but it's nice to add 2 lines of config and save minutes on each run. Now, this bias is not really useful information for you though. And with UV, the wheel sharing is a lot less important than before. I mean, it still makes a difference, but not as much as before. So I'm gonna say there are 2 main factors that for me make me use Nox. The biggest one being, do I need any logic in the Tox files that would inevitably lead to running shell scripts or Python scripts from it? Python is a perfectly adequate scripting language, and before I write an ini file to call a bash script, I just go with Python in the one place. The second reason is the handling of minimum dependencies. When you have a package that promises that it works with a certain version of a certain package, you have to test it to be sure it's true. This only reliably works with Tox by adding constraint files to the repo that duplicate information from package metadata and pass them as a dependency into your tox.ini. And that's kind of annoying and error prone and currently doesn't work with Tox-UV anyway, which does offer control over how to resolve dependencies, which is one of the coolest features UV brings to the table, but I couldn't make it quite work for my use cases yet. Now, with Nox, I can pass the constraint along with the install call, and it works, always, because it's just one call to pip or UV pip. But I can also parse the canonical metadata from pyproject.toml, extract the minimum versions, and pass that into my installation call. So it turns out this Python thing is pretty cool. So these are my reasons to go with Nox. If you have any other, I would love to learn about them in the comments. Please drop your wisdom on me, because I am done for today. Except for one thing, due to popular demand, there you go. Thank you so much for watching my already 4th video. I'm still floored by the great feedback, and I'm even starting to get weird comments, but it's a sign of success on this platform, so this is great. And now that there's more than 900 of you beautiful subscribers, and I look forward when I celebrate 1 million subscribers and link back here, I would like to know, what kind of content would you be interested from me? Because I'm still super new to YouTube because I'm publishing very slowly. And so far, I haven't run any strategy at all. I've just created videos about topics that organically came up somehow in the past 6 months. Yeah, it's been already 6 months. So let me know in the comments, especially if you know my track record from open source, blogging, and conference speaking. And speaking of conference speaking, I'm hectically trying to finish this video before leaving for PyCon US 2024 because my talk got rejected, so I'm a regular ass attendee and yeah, got this video instead. I didn't think I'd pivot from conferences to videos this fast, but here we are. Anyways, it's your chance to be the first person to come up and say hi and tell me you know me from YouTube. But seriously, come and say hi. That's what conferences are for. Finally, since no sketchy VPN providers or overpriced supplements peddlers with insane kickbacks are in sight, I would like to thank my GitHub sponsors, since they make it possible for me to spend money on video production equipment, which is not cheap, and justify the time on creating free content for everybody. And it would be great if you considered chipping in So thanks to everyone who sponsored me, at least at the visible patrons since my last video. So special thanks to my employer Vario Media. Get your domains and hosting there if you speak German. Tidelift is a huge sponsor of the open source ecosystem and has supported my work for years. File previews by Jose Padilla and Matthias Meyer of Inventory and InvenHost. Also huge thanks go to Sören Weber, Kevin Fleming, Daniel Fortunov, Magnus Watten, David Kramer, Jesse Snyder, Berg Jernström of Polar.sh, Chris Withers, Mike Fiedler, Duncan Hill, and Colin Marquardt. By the way, if I butchered any pronunciation, please contact me. As someone whose name gets mispronounced in every country except Czechia, I'm very attuned to the struggle. And of course, thanks to everyone who decided my work is worth their actual money. I couldn't be doing this without you. Thank you so much. And thanks to everyone who watches all the way to the end. This. Please like and subscribe. The algorithm still does not love me. And see you hopefully soon.